Hello students, now today we are going to start the topic that is displacement in a sound transducer. Displacement, that is a sound transducer. Okay, it is a capacitor transducer and it is a passive transducer. This capacitive transducer, it is a passive transducer. It is a passive transducer. Okay students, now we will see the how this capacitor transducer is looking. The diagram here, we will not say it is a diagram, but it is represented like this. Okay, something very first I tell you that my drawing is not so good, but still I am drawing this one. Okay, you may observe this diagram in the book also. I might think that it is the same figure might be in your book. Here you are getting the same portion. Like this, and the part which is used is this one. Okay, and in between there is a shape. This is the shape, half shape, like this. Okay, here you will be getting the some part okay. Now this part is being get connected to this portion, and here there is a winding. Okay students, and this is nothing but it is a fixed plate. And here whatever you will observe with this dotted line, it is a diaphragm. Here it is indicated like this. For your clear understanding, I am just drawing this one. You may observe this one in your textbook also. Okay, like this the portion I have just made visible to you. And what from here to here, this line is been get connected, and it is nothing but it is a insulation. It is the insulation, and this type of the device is nothing but it is called as a capacitor microphone. It is a capacitor transducer. It is the capacitor microphone. Okay, capacitor microphone. Now we will see how it is going to be work. You have to keep this in your particular point so that you may remember the first point, which is the sound transducer. A sound transducer converts sound energy into electrical energy. Sound energy into electrical energy. Okay, wherever there is a sound transducer which is being used, it converts that sound into the electrical energy. This capacitor microphone, it is similar to that of the capacitance transducer. Previous video I have shown you about the capacitor transducer. It is similar to that of the this capacitor transducer. It is a capacitor microphone and it is very much similar to that of the capacitor transducer. This capacitor it consists of fixed plate. This fixed plate I have shown to you. It is a fixed plate. This portion you are observing, it is a fixed plate consisting of a fixed plate and diaphragm Okay, this diaphragm it is activated by charging the pressure. When it will activate it, when this diaphragm will be get activated, it will charge to that particular pressure of a sound wave striking on it. As soon as it is get strike on this one, it will get charged, and this causes the diaphragm to charge, or you may say to change its position in relation to wave striking the fixed plate, wave striking to that of the fixed plate. Okay, whatever the capacitance in between the diaphragm and the plate charging corresponding to the voltage, it is produced across the resistor connected in series with a microphone and a charging sources. Okay, when you use this particular form, it you yourself will be get understood that how this diaphragm will be get pressurized and how it is being get charged. Okay, so here you have the disadvantages over this one. Also there is an advantage. First we will see the advantage. It is a low distortion. It is having the low distortion. Second advantage, it is having the excellent frequency response. Okay, these are the two advantages which is offered in this particular capacitor microphone. Okay, but apart from these advantages, there are also the disadvantages which is offered. What is the first disadvantage? The output level of this microphone is extremely low. Means whatever the value which you will be getting, it is very low. The microphone output level of this microphone is extremely low. Okay students, since if it is low, then what will happen? The high gain of the amplifier must be used with it. For gaining the high value, you have to use the amplifier. Since the high gain of the amplifier must be used with it for obtaining the exact position. It should be mounted directly to the microphone. This whatever the amplifier is being get offered, it should be get mounted directly to this microphone. Okay, this is all about the capacitor microphone. Then we will start the loudspeaker. Okay students, this is the loudspeaker topic. Now, as you are very unknown to you, that very well known to you, the loudspeaker. In this loudspeaker, you will be obtaining the coil and you are obtaining the cone. So it will look like this. Here Okay, whatever the triangular, half triangular part I have drawn, it is nothing but it is called as a paper cone. It is the paper cone. Okay, the next, apart from this paper cone, you will be getting here some resistance value which is connected, and it is shown like this. Okay, it is a resistance value. The second number which is being get connected, it is like this. From here 1 2 3 4, 1 2 3 4. Okay, here just I am getting to draw the diagram exactly so that you may observe the diagram in your textbook with the same figure. Okay, now this, here you will be getting the same value, this one part, and here you will be get connected with this coil. Here is a one small coil. Here is the portion which is get marked with a dark line like this, with the dark line, and in between these two, this it is nothing but it is a magnet. This and this, it is the magnet. This magnet is nothing but it is a tabular magnet. Tabular magnet. In between these two tabular magnet, it is been get connected like this. Okay, some dot marking we will show for this one. So it is a tabular magnet, and in between this one here there is a coil. Here this is the coil. This is the coil which is wound to this particular part. Okay, in between this one, here is also one coil which is connected to this magnet. Means it is not directly connected, but it is just just kept above this particular magnet. And this coil, it is nothing but it is called as a voice coil. Voice coil. Okay, students. And this one, whatever the part which is being indicated with this one, this part and this part, it is a soft iron pole. It is a soft iron pole. Okay, students. So from this particular voice coil, you are getting the two wire. That two wire is nothing but it is a flexible lead to the coil. So here you will be obtaining the connection like this. This is the two wire. This wire is nothing but it is a flexible lead of that particular coil. Wherever you will be obtaining this one, you will be observed in this positive and negative wire is always connected to this speaker, so that it is been get connected to that positive and negative terminal. Okay, it is a lead, flexible leads. It is a flexible lead. Okay, students. Now this loudspeaker is, it changes, I will write here, it changes the electrical quantity or electrical pulses from the amplifier into the mechanical movement of the speaker. Okay, I will not write all these things, but only for this explanation you will be saying that the loudspeaker changes the electrical impulses from the amplifier into the mechanical movement of the speaker cone to produce the sound output. Okay, whatever this paper cone has been shown, it is shown like this, but originally you will be observing this cone like this. It is just a semicircle part, but in your book also it is drawn like this. That's why I have drawn first time this one, but originally it will look like this. It will be of a black color cone. Okay, might now various colors is going to be seen by you, but generally it is a black color cone which is placed above, and you are observing whenever the positive and negative sign will be get connected with this particular coil, it gets bumps, and you will be seeing the fluctuations occurred in this one. So whatever the fluctuation is been get occurred, that conversion of that mechanical coil, that is a dynamic coil, this as shown, you will have one thing. It is important that it is a active transducer. Okay, it is nothing but it is called as a active transducer. So this active transducer in this loudspeaker, it is very much important. Might be asked in your examination also, what is this loudspeaker, it is called as a which transducer. So the question, your answer will be active transducer. The dynamic loudspeaker consisting of this particular voice coil. Okay, it is a center spidered coil, then the magnetic circuit, diaphragm, apex radiator, and the dust cap. Here there is a one cap. That cap is nothing but it is called as a dust cap. Here also one small cap is been present. It is a dust cap, so that dust should not enter, and this cone, the wires will be not get affected by any other harmful things. The two connections are made to the voice coil. These are the two connections which are made to the voice coil. When they are connected to the coil, the magnetic setup inside the coil, the magnetic is being get set in this particular coil, and due to that you will be getting some exposure to the magnetic field, and the voice coil and the speaker cone moves in and out. This speaker cone, it will get moved in and out. If we apply the alternating current to this particular cone, it reproduces the sound at it moves surrounding to the back and the forth, means from here to here it will get moved. We will just observe, but the moving is just this one, only from this portion to this portion it will get moved like this. Okay, whatever the vibrations is been get occurred, whatever the bits you are getting, the position it will get shifted to one to the another, and then come to the original portion. Okay, the spider allows this coil. Okay, this is the one soft iron pole. Okay, this is the soft iron cone or a pole, you may say that, soft iron pole. The loudspeaker does not require an external source of power through the signal power to make it operate. The magnet which is present at this outmost, it is nothing but it is a powerhouse. Okay, the loudspeaker main powerhouse is the magnet. Okay students, the magnet is the house power of a loudspeaker, and this statement is very much important. Okay, in a Viva question also in a 12th standard, at the end of the Viva, the project and all the completion, if any external ask what is the this speaker's main part, so you may say that the magnet is the horsepower, the magnet is the powerhouse of the loudspeaker. Okay, then I think this diagram is very much easy for you to draw, and whatever the theory I told you, you just write in yourself. The next thing, that is a gas sensor. The gas sensor. The gas sensor or gas analyzer are used to sense the presence of the gas. This gas sensor, it is used to sense the presence of gas. Presence of gas. Okay, since the name, the gas sensor, or it is also nothing but it is called as a gas analyzer or gas analyzer. Okay. In a present industry, when manufacturing process are to be called, it is controlled automatically, and it becomes essential to have the continuous working of the gas instrument. Okay, gas sensors are used in the following industries. Which are that industries? Gas sensor are used in different industries. Okay. The gas sensors are used in the different industries. So which are the industries? The first, to detect the hydrogen in atmospheric air to avoid formation of explosive mixture in laboratory. Okay. Then the next, we are using in a power plant. Okay. Why we are using this in a power plant? It is used for measuring the oxygen and carbon monoxide. This is the main thing, that's why we are using in the power plant. The third number, in ammonia synthesize the purity of nitrogen hydrogen mixer. Okay, it traces the CO2, it traces CO3 and the H2S. Okay, CO3, CO2, the quickly poisons the synthesis catalyst. And that's why we are using this as a gas sensor. Okay, it consisting of analyzing chambers and measuring the sections in which the measuring quantity is to be get transferred to the electrical current to the voltage according to the concentration of the component to be determined. Okay, there are the different types. The type 1, it is a thermal conductivity analyzer using the glass protected platinum wire. The second number, the paramagnetic oxygen analyzer using the glass protected heating spiral. And the third number, it is an infrared observed analyzer for the CO2 using the diaphragm capacitor. Okay, the first type is type number 1. We will be observing this type for the thermal conductivity. Analyzer using a glass protected platinum wire. Okay, in the industry also, the photometer for the gases and the liquid using the photocell, where the industrial photometer for gases and the liquid using a photocell. in all the types of the arrangement, from the zero adjustment and the temperature compensation by suitable compensation circuits are necessary. What are the different circuits? That circuits determines the different chambers. Okay, the gas sensor consisting of that particular four chamber. In that four chamber, the chamber 1 and chamber 2 are the measuring chamber, chamber 3 and chamber 4 are the reference chamber, and that chamber is being drawn like this. The four chambers are there. The chamber, here it is shown like this. Here there is a 1 meter, it is indicated like this. The likewise a meter bridge first we have to draw. This is the chamber, this is the another chamber. Okay, so this arrow and this arrow, it indicates the out value. Here there is a measuring gas in chamber. Here it is indicated with a C1, it is indicated with a C3, it is indicated with a C2, and it is indicated with a C4. Okay, from this point you have been get connected with the one rheostat value with a milliammeter and the negative and the positive supply, which is being get connected to this coil. Okay, here this portion we will cut this one, and here for the measuring value. So this will give you the input value, the output value. Okay, for measuring this one, as I told you, the C1 and C2, this C1 and C2, it measures, it is used for measuring chambers. Then C3 and C4 are reference chamber. Okay, in each of the chamber, the platinum wire of each dimensions and the resistance is exposed to the gas, and the four wires are connected as that of the Wheatstone bridge. Okay, in physics there is a Wheatstone bridge, students, so the connection is made same as that of the Wheatstone bridge. Okay, here it is the same part which is indicated. Okay, now the measuring gas, when it is in and the out, the measuring gas is passed through this particular measuring chamber to the certain reference. It is filled with a reference chamber. Okay, the zero adjustment, this is the zero adjustment which is indicated with this arrow, and this arrow here we have to attach the one galvanometer for measuring that particular resistance. Okay, when the gases through this, it is conducted to the lower and it passes through the measuring cell, to that particular measuring cell, the platinum wire, it is measuring chamber and cooled less. Okay, the temperature of the measuring chamber and the reference chamber is controlled thermostatically. It is being get controlled. The next, which is having this one, it is the temperature measurement using the thermistor. Temperature measurement using thermistor. Okay, here the temperature measurement using thermistor, we have a diagram. That diagram is this one. one resistor is this one, they are connected. Another resistance is again connected. In between this one you have connected the microammeter, and here one again resistance is being get connected, and here the thermistor, it is indicated with a T. Okay, all it is been get connected to the negative of the battery, this negative, and the positive is been get connected to this part. Okay, this resistance is having the value R2, here it is R1, and in between this one you are connected the part of the thermistor here. Okay, this gives you a temperature compensation network. This gives you the temperature session network, R1, R2, R3, and it is R4, the thermistor, it is also thermistor. Here the battery voltage, battery has been given to you with a positive and a negative terminal connected. Okay, so here it gives you the values of this one, the changes in the temperature per degree change in the temperature, whatever the temperature has been given to you, it is nothing but it is called as a sensitivity. As the temperature have the high sensitivity, they are the temperature transducer. This thermistor controls the sensitivity and stable fast acting. They requires a relatively simple circuitry. When the thermistor is connected in series with a circuit consisting of the battery and the milliammeter, this one, this battery and the micro, that is a milliammeter, you are going to make it connected. Here it is indicated with this one arrow, or you may write down here microammeter, and here the arrow like this also. Okay, this arrow indicate that is the ammeter is being get connected. The vibration which is being occurred by the temperature measures the resolution of the variations of 0.1 degree centigrade. Okay, the higher sensitivity which is obtained by the bridge circuit, the temperature compensation network consisting of that particular thermistors as shunted by the resistors. These are the resistors, which is being get shunted. The temperature with a negative temperature coefficient resistance, that is widely used to compensate for the effect of both the component and the circuit performance. Okay, the resistance, this one resistance, R1 resistance, it is having certain value, indicate the temperature changes with a 0.05, indicates a 0.05 degree centigrade, this resistor and this controller thermistor. Okay, so you will be getting the output voltage with a bridge circuit of 25 degree centigrade, that is nothing but it is a 18 millivolt per centigrade. Okay, so this gives you a transducer. Okay students.